This is problem 174 from chapter 12. A double collar C is pin connected together such that one collar slides over a fixed rod and the other slides over a rotating rod. If the geometry of the fixed rod for a short distance can be defined by a lemniscate, r squared is equal to 4 times cosine of 2 theta. Determine the collar's radial and transverse components of both velocity and acceleration at the instant. Theta is equal to 0 degrees as shown. Rod OA is rotating at a constant rate of theta dot is equal to 6 radians per second squared. Okay, so hopefully you're getting the hang of things by now. And in order to find everything we need to, we will start off by finding r and r dot and r double dot, and also we have theta is equal to 0 degrees, theta dot is equal to 6 radians per second. It's rotating at a constant rate of 6 radians per second, so if it's a constant rate, theta double dot is equal to 0. So I want to evaluate r when theta is equal to 0 degrees. Actually, I'm going to rewrite r first because it's going to help later when I take the derivative. So we have 4 cosine of 2 theta, then evaluated when theta is equal to 0 degrees. That gives me cosine of 0 is equal to 1. Ooh, I missed something here. Because this is r squared, this is supposed to be the square root, right? Because r squared is equal to this, so r is equal to the square root of that. So I guess it's a good thing that I rewrote it. So now you put in 0, you get cosine of 0, which is equal to 1, and then you take the square root of 4, and you get 2, and the units here were feet squared. So that's feet. Now we take the derivative. So I have this constant 2. Then I take the derivative of cosine of 2 theta to the 1/2. So we're going to use the chain rule multiple times here. So first, because it's raised to the 1/2 power, we lower the power, multiply by the old power. So now it's cosine of 2 theta to the negative 1/2. But then we take the derivative of what's in parentheses, and the derivative of cosine 2 theta is minus sine 2 theta. And then we take the derivative of 2 theta, and we get 2 theta dot. Evaluated when theta is equal to 0 degrees and theta dot is equal to 6. Well, that doesn't matter because you have sine of 0 degrees, and that is equal to 0. Now we have to take the derivative again. However, if we think about what we're going to get when we evaluate this, when theta is equal to 0 degrees, it will make taking the derivative a lot easier. Otherwise, you'd have to use the product rule, but recognize that because sine of 2 theta is equal to 0, if you do the derivative of cosine of 2 theta to the negative 1/2 times everything else that you have here, when you plug in 0 degrees for theta, this is going to be 0, so that part doesn't matter. So then it would be everything else times the derivative of negative sine of 2 theta, but when you plug in 0 for theta, cosine of 0 to the negative 1/2 is just going to be 1. Oh, and 2 divided by 2 is also 1. So we have 2 times theta dot. And then we take the derivative of negative sine 2 theta, which is going to be negative cosine of 2 theta, evaluated when theta is equal to 0. So let's just say negative cosine of 0 degrees, but then we have to take the derivative of 2 theta, which gives us another 2 theta dot, so this becomes that squared. I think that's everything. We would actually need to use the product rule and take all of this times the derivative of 2 theta dot with respect to time if it weren't that sine of 2 theta is equal to 0. So the only term that's not 0 is when you take the derivative of negative sine 2 theta and multiply it by everything else. Hopefully that made sense, and if it did not make sense, you can go through it and take the derivative on your own and make sure that everything works out. Okay, so theta dot is equal to 6. Cosine of 0 is equal to 1. We have the negative sign here still, so this is negative, this is 2 times 6 squared, and so that's 12 squared. That's negative 144 feet per second squared. Well, now that I have r dot, r double dot, theta, theta dot, and theta double dot, I should be able to find all the components that I need. From looking at this equation here, I should hopefully be able to see that the radial component of the velocity is just equal to r dot, so that's 0. The transverse component of the velocity is r times theta dot. R is equal to 2 feet. Theta dot is equal to 6 radians per second. That gives me 12 feet per second. Remember, the units of radians come and go for free, so we can just get rid of them if we don't want them. For the acceleration, the radial component is r double dot minus r theta dot squared. R double dot is equal to negative 144 feet per second squared. R is equal to 2 feet. R theta dot is equal to 6 radians per second squared. That is negative 144 minus 6 squared is 36 times 2 is 72, and that's feet per second squared, and that is equal to negative 216 feet per second squared. So we have one last component to find. That's the transverse component for the acceleration, which is r theta double dot plus 2r dot theta dot. Theta double dot is 0, so that first term is 0, plus 2 times r dot, which is also 0. Okay, so that is equal to 0, and that concludes problem 174.